And we are live. Hello again, once again, ladies and gentlemen. Thank you very much for joining us today. Today's webinar is about creating intelligent apps with Azure AI. As usual, I am your host, Hans Armida, Cloud and Enterprise Business Lead for Microsoft Philippines. And today's topic is going to be all about how we incorporate Azure AI in different forms into your applications. Just a few rules before we start the webinar. As another reminder, this entire webinar is actually recorded. You can listen to it from beginning to end, or you can start in the middle, whatever you want. You will actually get a URL of the recording of this webinar after about 24 to 48 hours at the end of this webinar, where you can access that said recording. Due to confidentiality reasons, unfortunately, I won't be able to send you the slides of this webinar. So the only way that you can recall whatever was said in this webinar is to just read through or just listen through the recording that you will get at the end of the day. All right, so let's get through it. Azure AI is about making AI real for every developer in every organization. A few years back, we have set in Microsoft a direction that we are going to democratize AI, which means that we will make all of our tools available to every developer in the world as they are produced by our research labs in order for developers to be able to incorporate AI into practically any type of application today. So here are a few examples of our customers who have gained substantial business benefits in incorporating AI into their businesses, into their application. For example, let me just cite a few ones, like Rockwell Automation has achieved $300,000 of cost savings per day by incorporating AI into the way they monitor all of the equipment that they manage. UPS, for example, has decreased the cost of their customer service by incorporating chatbots, which is now interacting with an average of 200,000 customers per day. TAL in Australia, because of AI and because of the recommendation engines and machine learning, has increased more than 40 times the number of insurance cases they have reviewed, which increases the efficiency of how they conduct their business in terms of renewing insurances and therefore increases their revenue. There are many, many examples of these, and you will get to know them during the course of this webinar. Azure AI is the thing that powers all of them. And this is again the focus of the entire webinar today. We'll be showing some more examples on how we incorporate and how the AI components actually work. It all starts with breakthrough research. All over the world, we have Microsoft research organizations that are in Redmond, New York, in Europe, as well as in China and in India, in some parts of and some other parts of the world. And these are dedicated Microsoft research professionals that are producing breakthrough AI research that now produces things such as produces AI that is now at par with human beings in terms of speech recognition, machine translation, conversational QA with human parity, and also object detection with human parity. So all of these capabilities, we continue to invest in research. We spend billions of dollars in research every year, and the output of this research, once they become production ready, becomes part of our AI portfolio. Azure AI is also embedded in across all of our cloud services, and these are just some examples. In our Bing search engine, there are about 280,000 ad insights recommendations that are done on a daily basis. Every user of Office 365 has, without them knowing, are actually using AI. So one example of that is PowerPoint Designer. Unfortunately, I won't be able to demonstrate that today, but for those of you who know how this works, whenever you create a PowerPoint presentation during the edit mode in PowerPoint, PowerPoint Designer actually uses AI to give suggestions on how you can design your PowerPoint slides better. And in Xbox.com, 6 million personalized experiences are delivered daily. And these are again delivered through the AI capabilities that have been produced by our Microsoft research facilities, and they are now embedded across these three different cloud-based solutions. And the good thing is that because this is artificial intelligence or AI, the more people use it, like the more people use Office 365, the more users play games on Xbox.com, and the more users use Bing for searches, the AI becomes smarter, and therefore the results become better and more accurate. But Before that, let's take a look at our investment principle in terms of Microsoft AI. First is that we have to produce AI capabilities that are productive, which means that you can incorporate these AI capabilities in any language from using any developer skills at any skill level. We have different types of AI capabilities, as you will see later on. Some of them require no programming at all because they have already been pre-trained. Some of them require, and on the other end of the spectrum, there are other AI capabilities that need to be programmed and required some level of skill in terms of AI machine learning languages such as Python or R. These AI capabilities must also be built for the enterprise so that it can work at any scale with each existing system or process regardless of the size. And then the third principle is that AI must be trusted. We continue to hold to our tenets that you own and control your own data, even if we use even if we use your raw data to train our AI and train our AI capabilities to give you better results. So Azure AI, moving forward from this webinar, we will be referring to each of these capabilities according to three different categories: AI apps and agents, knowledge mining, and machine learning. Let's start first with AI apps and agents. AI apps and agents basically means is that you're incorporating pre-trained or shall we say framework type of AI capabilities into applications that are already existing. Think about a scenario where you have, for example, a mobile application that you may already have, and you would like to give this mobile application the ability to interact with the person or the user via a chatbot in a very human-like fashion. You can also incorporate Azure Cognitive Services, like for example, giving your application the ability to see the world, hear the world, or even do speech transcription. So take for example, you may want to have an application that can scan receipts using the built-in camera of a mobile device. So the scanned receipt will then be OCR'd or using optical character recognition. AI will extract the data or what is written in the receipt that you have just taken a picture of and store that in a database. Let's take a look at the different Azure Cognitive Services first. So roughly they can be classified into language, vision, speech, and web search. We have also created a new category of cognitive services called decision. So I want to spend some time using that. Decision essentially is implemented by a capability in Azure Cognitive Services called the Personalizer, and yes, it does what the name is. It is used for as a personalization engine by some of our biggest customers. Imagine the personalizer taking in a lot of your informed preferences or the way you interact with an application or what products and services that you buy. And the personalizer is the one that actually makes personalized decisions based on all of these attributes. I'll show you one concrete example of that later on. Ink Recognizer is also one of the capabilities that we put in as part of basically means that if you use handwritten text, so for example, if you are using a touchscreen PC and you use the stylus or your finger to literally write something on the screen, the AI vision capability will be able to translate what you've written into actual text. This can also happen with handwritten documents. So you can take a picture or scan a document that has handwritten text, and the vision ink recognizer capability will translate that to actual text. In terms of speech, we now also have conversation transcription capability. PowerPoint or even use Microsoft Teams. You already know that there is an inbuilt or built-in transcription capability. So when someone talks to an application, say for example PowerPoint, the mic picks it up and AI then transcribes whatever you are saying in supporting hundreds of different languages into written text. And we are also providing new updates across the board. Like for example, vision, we continue to enhance our computer vision services. Say for example, under vision, you can give your application the ability to recognize everyday objects. For speech, we have text-to-speech. And for decision, we have also anomaly detector. So this can be applied in scenarios wherein you have for example, in the case of a factory, and you have a camera that takes a look at all the products that come out of the factory floor, and anomaly detector will detect whether there is a defective product. Language also, we also have capabilities such as language understanding. The interface here has the ability to understand the context of languages in the English language, for example, to understand the true meaning of what a user is actually saying. Full capability set of all of our cognitive services, as you can see here on the screen. Under vision, for example, we have face recognition technology, which has been around for quite some time now. So face recognition basically means that you can actually train the cognitive service to have a database of faces, and we have a number of customers that are already using this capability to do facial recognition and facial login. You can also do custom vision, for example. Custom vision basically means is that you have you can actually train the vision service to recognize non-everyday objects. So my favorite example here is a very popular beverage company. They're one of their most popular products. They have several versions of the label. So they have to train the vision service to understand and recognize each of these labels one by one. So personalizer in action, you can see that in if you're an Xbox gamer, if you use Xbox, personalizer kind of works this way. I actually have an animation here. So say for example you are a user, and the moment you play Xbox, you generate a lot of metadata, your gaming style, the weather, when you last played, achievements, the day of the week, and so on. And all of the gamers that actually run Xbox have the same capability. Now, if you were a data scientist, the way you would approach personalization is that you would have to define your goal, your options, and your data, mark the data levels, create a machine learning model, train it, and then test it against the users in your in Xbox.com in this case. This is a continuous process where you continue to get feedback from the user and continue to refine the model. Personalizer, on the other hand, takes a different approach. Instead of creating a model, the model is already built. All you need to do is define what goal you want to achieve and what are the data points that you want to capture and put that in Personalizer. The user then generates, during the course of the playing of the game, generates all of this metadata, which is then ingested by the Personalizer. The Personalizer then automatically creates personalized capabilities, such as, for example, gameplay. If it makes a suggestion for a user to watch something, and if the user doesn't want to watch it, then the score goes lower. And then you can imagine this scenario going on and on and on until the personalizer learns through different experimentations with the users, and all of this happens automatically. Over time, personalizer will continue to learn, or will learn what the preferences of each users are. The more users use it, the more it will be better. So the result for Xbox is that it created 40% lift in user engagement. The other bits of the Azure Cognitive Services is that we have some of these cognitive services that already finds its way to wherever your data resides. So whether it's not just on the public cloud, but also you can find some of these capabilities embedded into edge devices already. So one example of that is some drones that are flying around already has some of the vision recognition capabilities within the drone operating system itself. Some IoT devices also have that capability as well without having to connect to the public cloud all the time. So it also now can do container support. So some of the cognitive services that I have just discussed before, you can actually run that on container that can be managed using a container management system, or such as Kubernetes or Azure Kubernetes services. So some of these capabilities that can now be supported on containers include anomaly detector, speech to text, and text to speech. Now let's change gears. We have a number of customers already that are using our bot framework to create chatbots. So this is essentially bots wherein the user is talking to a bot via a chat interface, either through Facebook Messenger, which is one of the most popular chat platforms, Skype, or any other type of application. In fact, we have a few customers wherein their chatbot interface is actually embedded within the website or the mobile application that they themselves created. But the actual bot was developed and created using a framework. This is built with open source tools. We currently have about 2 million plus SDK downloads, and you can easily deploy this as a service because we already have a managed Azure bot service. There are currently about 35,000 active bots in the world today that's being managed by or run through the Azure bot service, and 3,000 new bots are created weekly. Now, how do you train these bots? You basically create a set of frequently asked questions, a question answer pair, if you will, and then put that essentially into the bot framework, and then continue to train the bot by exposing it to different types of user conversations. Over time, while the bot is talking to more and more people, the better it will learn, the better the responses will be over time. So we've also got accelerators. And one example of that accelerator is the virtual assistant solution as accelerator, because sometimes you don't want to start a bot from scratch. So therefore, we already have pre-built accelerators that you just need to train so that it can learn how to service chatbot inquiries from users in various situations, for example, such as customer service. So one of our best examples, this is one of my favorite examples, is the Progressive Insurance Company in the United States. So if you are, if you watch a lot of US TV, you actually see their commercials. The lady there that you see there in front of you is a character named Flo. She's a very recognizable figure. She represents the brand. In fact, the chatbot that you chat with in the Progressive Facebook Messenger website is called Flow. That's the name of the chatbot. So you can do anything with the Flow chatbot, including inquiring about the latest insurance products, asking where the nearest Progressive office is, and asking for detailed questions such as how to compute for premiums or penalties of your items that you are insured. So they are one of our more successful customers out there. Here's another example of a chatbot, but this time, this chatbot is an internal enterprise chatbot. So this is what Unilever is currently doing. You can see here in the example, I apologize if this is very fast, but if you can follow along this example, instead of filling up a form, you actually write down the chatbot asks you questions such as what is your name, what is your birth date, where are you born, and so on and so forth. Instead of filling up a form, you answer a series of questions that are being asked to you by the chatbot. So a lot of people don't like filling up forms, but most people like chatting with the chatbot, such as this one. So in this example, you're not filling a form, you're actually chatting to fill up a form. So some bot use cases include the three most common ones: the commerce chatbots, which create conversational interfaces for various scenarios such as banking, travel, and entertainment. We have hundreds of customers, for example, in the banking industry, wherein you can do chat-based banking. So once you log on, for example, you can do things such as inquire your balance, ask for details about different products and services of the bank, and so on. Information chatbot is also a very common scenario wherein the chatbot actually answers questions in a knowledge set or an FAQ. So you can ask things such as where is your nearest branch, what is the latest in the menu of a particular restaurant, what are the latest exhibits in a museum, and so on. And then finally, the previous example of the Unilever example, wherein you don't fill up a form anymore, but rather answer questions from a chatbot in an effort to fill up a form in the background, is called an enterprise productivity chatbot. Architecturally, this is what it kind of looks like. So a commerce chatbot is centered around the Azure bot service, as you can see here. Let me just point that out. The Azure bot service is where the bot actually runs, but this is embedded in an application that is served out of the Azure App Service. And then the user uses a device, either a mobile device or a web or an app server, or web or an app, or it can be using voice. So remember, we also have a cognitive service that's already available out of the box that you just have to incorporate in your application via an API, wherein you literally just have to talk to the application. It will transcribe the speech into text, which then goes into the chatbot that will reply appropriately via text or via text to speech. So it also incorporates language understanding so that it uses, for example, cognitive services to help process the natural language request. And then once the user is happy with the question and answering or the result of the conversation with the chatbot, you can store the result in a SQL server. For information chatbot, it's the same architecture, except that in this example, you now have Azure Active Directory because you want to authenticate the user first before the user proceeds to ask questions from the chatbot. The other thing is that since this is information chatbot, you literally have the Azure bot pulling information using Azure Search from a database, for example. And then for an enterprise chatbot, it gets a little bit more complex now because you have additional components. Not only do you have the Azure bot service, but it uses speech API to understand what you're inquiring for so that it can redirect it appropriately. You may be, for example, asking for interacting with the chatbot to answer questions of which your answer will end up in Dynamics CRM or in Office 365, say, for example, a SharePoint form. All right, so those are AI apps and agents. So we just discussed about what are the different cognitive services that are available. We have vision, speech, text, language understanding, and ink recognition, handwriting recognition, and so on and so forth. Now let's go to the second category, which is knowledge mining. But first, let's define what knowledge mining really means. Knowledge mining means uncovering latent insights from all of your content. Now, here's the reality. This slide is representative of what is happening in your enterprise today. You probably have hundreds, if not thousands, of pages of documents that are in Microsoft Office format, in TIFF format as an image, in HTML format, in PDF, scanned images, handwritten images that have been scanned, typewritten documents that have been scanned, and so on and so forth. So the question is, can you actually extract knowledge from all of that content? The answer there is yes, because we can then use Azure Search to do all of that. The first step is to get all of that content, scan it in electronic form. So if it's a Word document, you leave it at the .doc format. If it's an Excel document, you leave it in its native format. If it's a paper document, say for example, a form that has been filled up using a typewriter, a traditional typewriter or a handwritten form, scan that image and store all of that in the cloud. Once all of them are in the cloud, Azure Search then uses knowledge management to ingest it by using things such as language detection, face detection, and so on and so forth to understand, for example, this piece of paper or this form, what language is it in? Is it in English or Japanese or whatever? Once it already detects the language, then you can invoke additional capabilities such as translation, translating the Japanese text in the form into English if you want to. It can also do face detections because, as we know, a lot of documents that you may currently have actually have pictures of people or images of scenes or objects. It can also get organizational entity instruction location. So, for example, if you have an address in the form, the Azure Search will actually get the location data and key face extraction. The next step that it will do is that from the document, it will generate metadata. For example, if this was a resume, for example, it will extract key data such as your experience, the first job, the second job, the third job, what is the name of the responsibility or the job description, the company, and the duration. Can also get your picture if this was a resume that has a picture, and so on and so forth. From the paper form or the paper resume in itself, it now goes into an index, and now you can now search across the documents. So in this example, you can now search, say, candidates with 5 years experience. It goes into the Azure search system, and the result that will be pulled out is the image of the resumes that matches your search results, search query. So example is not just doing search across the documents or the documents that you have on the cloud storage, but also storing them as in a database, either in a JSON database or a structured database. So what it's essentially doing is that you're getting all of the documents searched, Azure Search then gets all of the metadata scanned using the different AI capabilities, and then you can put them on a database. It's already in a database, you can do whatever you want. Now, the good thing is that it's quite easy. It's effortless, just structured and a structured data. So here in this example, you can, for example, point it to Azure Blob Storage, and then Azure Search will automatically search for all the content in the blob storage. So to configure, there's no coding required. Once it has already scanned all the documents or all the images that you have in database, all the attributes that it has found. So for example, if it was a set of forms, you just simply use a checkbox to determine what fields in the form would you like to be indexed so that it can be searchable. It also has rich search features that are out of the box. So part of the capabilities of Azure Search is to give you this search form so that you can immediately embed this in, you can embed this search form into existing applications, or you can embed this to mobile applications. And remember again, we have speech to text capability. So you can in order to allow for users to do voice-based search, meaning you have to talk to the application to do a search, meaning saying the search term instead of typing at it, you can also do that as well. Quite easy. It's quite easy to scale and maintain because all you need to do is just to have a slider here in the Azure portal to easily increase the volume and the capability of your search capability. So for example, if you find that your search is becoming slower, you can just simply go to the portal and increase capacity. You can also integrate a lot of capabilities. So like I said, you can analysis, tag extraction that's already built in to the Azure Search capability. So if you have a JPEG form, for example, it will produce all of the items that it sees from the form. Incorporate language like key face extraction, language detection, sentiment analysis. Like you can find out things such as the name of organizations or locations from the documents and key phrases from the document. From an orchestration standpoint, you can then use text manipulation. You can put in custom skills, image store. So for example, we know of some customers that not only use the built-in capabilities of Azure AI to do language detection and location entity, but you can actually create, for example, a custom AI to recognize different organization names that may not be commonly known. So essentially, you're training the AI to understand entities that can be found in certain documents. And finally, it's readily customizable. You can optimize your search experience by integrating your own data and create custom models and classifiers. Data if you want to. So for example, if you have different types of documents, this is the different types of documents that are supported. By default, you can get text, images, or you can even define custom metadata if you want. Create custom models and classifiers. So for example, one example is that it out of the out of the box, or quote unquote out of the box, Azure AI can recognize a lot of locations, can actually recognize a lot of key phrases in English, but you may want to create custom item models and classifiers. Say for example, you are extracting key phrases such as SKU numbers, which are unique to your business. Extend to specific industries or businesses. So we have hundreds of partners that have already created custom AI models to recognize key objects or key points or key objects or within documents that are typically found on certain industries such as banking or manufacturing. So once you've already gotten all of the data into a JSON file or a database, you can then visualize that into Power BI. So we have one customer today, for example, that wants to identify, for example, how many people from a certain locality or certain geographic area do they have in their database. So instead of querying the customer database itself, you can query the different registration forms that the customers has filled up long time ago, which now you have scanned and put into the Azure search system. You can also do, because you have the data, you can now predict using Azure Machine Learning, and you can then infuse that into your applications as well. So one pretty exciting capability of Azure Search is uncovering insights from forms. So this is just a example of a few forms. So whenever you go to, for example, a bank or government entity, or if you want to apply for a loan or apply for anything, they usually like to ask you to fill up a form. Now, Azure Search together with Azure Cognitive Services. So you can start with any type of form, whether it be a housing loan form, a car loan form, medical form, etc. And using Form Recognizer, you can quickly extract tables and key value pairs with simple REST API calls. So for example, in a standard form, you can literally batch scan these forms and then send them up to Azure Search, and then the form recognizer will take a look at the first name as the form field, and then whatever you've written down or typewritten there. Remember, we also have ink recognizer. So the ink recognizer then takes a look at all the handwritten entries that you have put in the form and translates that into text. So the result here is, here's a great example. So you may have, for example, you may be, say, for example, you're a hospital, and then you're asking people to fill up a standard form. If you have hundreds of pages of these forms, you just simply scan it using a high-speed scanner, put them up in Azure, and let the AI do the work in extracting field value pairs such as bill to, phone number, invoice, fax, and all of this data and all of this information that you saw in the form. All right, so that's knowledge mining. So knowledge mining, to summarize, is the ability for Azure to take a look at all electronic documents. It may be forms, it may be images, it may be text in different languages, as long as it's stored on Azure storage. Knowledge mining, the Azure search capability can look at all of these, all of the content, classify them according to key value pairs, put them on a database, and from there you can do anything you want. You can translate the written language or into different languages. You can translate the handwritten points in the forms into actual text, save them on a database, and then you can do whatever you want after that. Now, if you're not satisfied with all the built-in out-of-the-box capabilities of cognitive services, bot framework, and all of the capabilities that form part of Azure Search and knowledge mining, we certainly have a machine learning platform so that you can create your own machine learning capability, if you will. Machine learning on Azure, if you look at from top to bottom, like I said, we have domain-specific pre-trained models for vision, speech, language, web search, and decision. You can use any familiar data science tools. It can be Visual Studio Code, Azure Notebooks. In the data science community, Jupyter Notebooks are also very popular, or even command line. If you're already used to creating machine language capabilities using PyTorch, TensorFlow, ONNX frameworks, you can definitely continue to use those frameworks and then make them run on Azure because they are supported. You can then use different types of services to make your machine learning capabilities scalable and run in virtually unlimited scale. So it can be Azure Machine Learning Service, Azure Databricks, or dedicated virtual machines just for running machine learning code. And then underneath it all, you have we have thousands upon thousands of servers across 54 data center regions all over the world where you can execute machine language code on CPU, GPUs, or FPGA. And all of this, you can do it from the cloud all the way up to the edge devices. Azure Machine Learning is for all skill levels. You can do automated machine learning. You can drag and drop, or you can do a code-first approach. It also is an industry-leading MLOps. It's integrated with Azure DevOps, which I will explain later. It's also open. In terms of it being for all skill levels, this essentially means that you have three ways to create machine learning capability. One is to use the automated machine. So once you create your experiment, you select the source data that you want the machine learning to look at, create the type of algorithm that you want, and then look at the results. And then essentially, it's a continuous process of selecting the appropriate algorithm to fix or to solve the problem or to solve the classification problem or the learning problem that you want. So it's a method of selecting selecting the data or uploading the data and then selecting the algorithm. The visual interface approach, on the other hand, uses a drag and drop Azure Machine Learning Studio interface for you to create a workflow, if you will, to get data to get your raw data, classify some of the raw data into the learning set, and classify some of the data into the evaluation set, select an algorithm, and then click on run to run the algorithm for the machine learning model to start applying the algorithm into the data set. And then afterwards, you will see the result. And then once, if you're not satisfied with the result, then you can simply make a few changes. Either change the data set, add an additional rows in the data set, or change the algorithm. People like the code first approach, which means that you have machine learning notebooks. You can create it in a Jupyter notebook, and then from here you can then incorporate the code that you typically would create using Python, PyTorch, or R, or any other machine learning language. And then you can run that across our machine learning infrastructure via Azure Databricks so that it can run at scale, or can learn, or it can execute at scale. Industry leading ML ops. Um, this. So in DevOps, you know that the objective of DevOps is code reproducibility, code testing, and the ability for you to do app deployment and testing the application towards end users, and then getting feedback from the end users so that you can continuously improve the code. ML Ops, on the other hand, uses the same approach more or less from DevOps. You have model reproducibility, you have model validation, deploying the model, and then retraining the model based on how users or how applications are interacting with the machine learning. This is how it works. If you're an app developer and you're using Azure DevOps, you collaborate using different tools. So as you can see here in the diagram, it can be a mix of first-party Azure tools for DevOps, or it can be a mix of together with open source tools. So for collaboration, you use GitHub, you use Visual Studio Code to build the app, then test the app using the Visual Studio Code testing capabilities, release the app, and while the users are using the application, you then monitor the applications, and then whatever insights you gain from the operation of that application then gets fed back to the developer so that you can continuously making changes to the applications to improve it. So the same approach can be done by the data science. You can create your machine learning code, whether you're using a code first approach, you're using the visuals, the machine learning visual studio approach, or you can use built-in, or you can just use a selectable machine learning model that you train. You train the model, then you validate the model using machine learning capabilities on Azure. You embed that into the application so that you can deploy it, package it. You monitor the usage of the machine learning model, and then feeding it back to the ML model so that you can continuously refine the machine learning model so that it can continue to learn. So a practical example of this is that you may, for example, create a machine learning model to do predictive maintenance. So for example, you want to predict whether a certain piece of equipment will fail after a certain amount of time. Now, you'll have to accept that the first runs of this prediction model will not be super accurate. So this is why the data scientist in this case will have to continuously refine this model as it continues to go to be in production, and to learn from how the users are using it and what are the different types of inputs it is getting. So essentially, you have machine learning extension for Azure DevOps. Now, how do you then deploy the model? Once you've already created the model, you've trained the model, and you're satisfied that your model is already trained, it can take on any type of situation, it can accurately predict the result. You can then deploy it with Azure Machine Learning. And in the background, you can actually determine that this machine learning model will be executed by field programmable gate arrays, or FPGAs. This is way faster than CPUs and way faster than GPUs. These are specialized hardware accelerated deep learning, because the machine learning model takes advantage of the speed and the scalability of FPGA. The third thing about Azure Machine Learning is that it is also mean by open is that it is an open workflow. You can use native ML flow support, ONNX runtime updates, and also using Azure. So as a result, machine learning can be used across different types of scenarios, whether it's marketing, sales, service, finance, operation, or workforce. So in marketing, for example, the most common use cases are product recommendations, customer insights, and analytics, whether a customer will churn or not. Sales includes lead scoring, sales insights, dynamic pricing. Service, you already seen examples of chatbots, like the progressive example that I said a while ago, virtual assistants, finance for financial forecasting, and so on. We've actually created two accelerators, an additional two accelerators for predictive maintenance and also demand forecasting. So the machine learning models for predictive maintenance and demand forecasting is sort of pre-built already. So you just need to pull it out of the marketplace so that you can start customizing according it to your build. So you don't have to start from scratch. So some transformational scenarios for machine learning includes, like I said, product recommendations. ASOS, for example, uses machine learning, custom machine learning. This was before we released the personalizer capability, by the way. So they created their own machine learning model using open source tools and deployed it on Azure so that they can determine the average size of a single cart. They can now increase the cart size and provide digital content that are personalized to the shopper. Schneider uses machine learning to do predictive maintenance, to predict unplanned downtime as a result that results in cost overrun. They can also predict when maintenance should be performed, and it also minimizes the downtime. Sherwin-Williams is another customer of ours that uses machine learning to do demand forecasting, like how much manufacturing process and labor hours are required given certain conditions of the business. And there are many, many financial use services use cases, as you can see here. So if you're looking or listening to a recording of this webinar, you can stop at this point and see the different use cases. So the most common use cases in finance that we have seen so far include customer analytics for customer 360, understanding the way customers are interacting with the bank so that personalized products and services can be provided. Financial modeling, risk, fraud, and threat detection, credit analytics. So we have many examples of customers using custom ML models running on Azure to determine whether a customer is a credit risk at the transaction level or at the customer level. And also marketing analytics in order to improve customer engagement. Very common examples in retail would include data-driven stock inventory and ordering. So you take out the guesswork of whether you need to restock certain items in your inventory. Next best and personalized offers, as I said a while ago. Understanding store layout, like store design and ergonomics. Understanding, for example, where customers are going inside the store with the combination of IoT devices to determine where customers spend the most time in the store and then make recommendations on how to relay out the store to maximize revenue of that particular store. Some customers even do real-time pricing optimization. So you can only do this, for example, on a mobile site or a website. So depending on things such as personalization items such as attributes about the customer and the volume that customer is buying on a number of items, the price can change as well. And we also have different various use cases for machine learning on security, intrusion detection and predictive analysis, security intelligence, fraud detection and prevention, security compliance monitoring, and fine-grained data analytics security. So all of these examples are actually happening live on Azure today through the different security capabilities of Azure today. One example is the Azure Security Center. The Azure Security Center is a solution and a service on Azure that can, for example, take a look at everything that you're running on Azure today and then gives recommendations on what you need to do in order to increase your security standing and to increase your security score. It also has predictive capability so that it understands whether or not your website or your application is vulnerable to intrusions once the intrusion has actually happened. So I'm cheating a little bit over here because all of these use cases are actually live on Azure Security Center today. So there you go, folks. You've now seen a number of examples of Azure AI classified under AI apps and agents. knowledge mining, and machine learning. So I hope during those minutes in past in this webinar, you've seen some examples and and the capabilities of Azure AI today, whether it's pre-trained AI in cognitive services and bot for in chatbots in AI apps and agents, and or the ability to create search capabilities in understanding forms and understanding inputs, whether it's handwritten or typewritten via knowledge mining. All right, now we are now at the end of our webinar. So let me just give you a few more reminders, a few more commercials before we officially end. You can still get your Azure free account by going to azure.com/free. When you go there and sign up for your Azure free account, you will get a $200 credit plus 12 months of popular free services, which is not going to be counted against your $200. 25 services. I'm sorry, I apologize for that. So these are the services that will be using your $200 credits. If you stay within these limits, your $200 credits will remain intact. But the moment you go over these limits, say for example, if your SQL database goes over 250 gigs, then it will start charging against your $200 credit. If your credit goes close to zero, you will get a friendly email and a reminder in your Azure portal and asking you if you want to still continue using the service by charging your credit card or getting a contact from a partner to continue to use the Azure services. And these are all the services that you're going to get for free without being charged against your $200 credit. Where do you get training? You can get this from Microsoft Learn. Okay, remember that Microsoft Learn. You can Google Microsoft Learn or search for Microsoft Learn or go to that URL in the bottom. And you can, when you click on select your role, you select what role you're currently performing in your own organization, and the training content will automatically be chosen for you. So if you chose, for example, data scientist, it's a combination of video training, instructional training, labs, code samples, etc., so that you can learn how to become a data scientist and apply your data science capabilities within Azure. Or if you just want to be an administrator, I believe everybody starts with administrator. This is how you learn to become an Azure administrator. To a certain extent, you can use these learning tools to prepare for Azure certification exam. There is a specific school for AI called aischool.microsoft.com. This is where you can learn how to create chatbots on our conversational AI platform, creating machine learning and advanced analytics capabilities. And we also still have academy.microsoft.com. This is soon going to be replaced by a new program, but if you sign up today, you can still continue even after it is phased out. The one thing I like about the professional program is that this is a set of instructional courses a la EDX, a la TED Talks. And the instructors are not just from people from Microsoft, but also professors from schools that are renowned for their artificial intelligence program, for the data science program, for the big data program. So I usually recommend this academy.microsoft.com. So if you want to start a data science career but don't know exactly what data science is, this is the first place to start. Then you can go to Microsoft Learn and learn how to apply your data science concept on tools specifically on Azure. Complete documentation is on Microsoft Docs. So this is our this is where every Azure professional goes to for anything for administration, for code samples, how to architecture, cloud adoption frameworks, best practices, etc. If you're not satisfied with the learning, you can also, of course, get virtual training and classroom training. One of our friends is CloudSwift that provides, for $99, will provide you a self-paced course material, an exam voucher for proctor exams, and also hands-on practice labs with the virtual instructor to help you learn concepts on Azure. So this could be data engineering, AI engineer, even Microsoft 365 or Dynamics 365. You can get a discount from CloudSwift by just using the promo code that you see there at the bottom and tell them that you got this promo code from listening to this webinar. One of our other training partners includes a company called DLLS. They do conduct classroom courses Azure, on Azure fundamentals, becoming Azure architect and an administrator, and also developing solutions on Microsoft Azure. So our friend Tofen, the country sales manager, you can reach out to him to get a 10% discount. There's the promo code right there at the lower right hand corner and tell him that you got this promo code from this webinar. MISNet is also one of those training centers which has been around for a long time now, and this is the list of their courses on Azure. Microsoft Fundamentals, Architect Design, Azure Architect, Azure Administrator, and Security, and so on and so forth. So they actually have a pretty good bundle deal that includes training exam, a retake of the exam, and also a practice test. If you want to avail of this special package, reach out to them. Their contact details are there at the bottom. And finally, NTT Data also offers the same set of Azure courses. You can see the course right there at the right side. If you want to get discounts from these guys, you can just tell them that you got the discount code from listening to this webinar, and the promo code is right there at the bottom. All right, so this is the end of our webinar. I believe the next webinar is going to be all about creating intelligent apps with AI. This is going to be on the 23rd of October. The day after that, we'll have a webinar on open source apps on Azure and how to run them on Azure. And you have the rest of the webinar scheduled for the rest of the year. We still have a few more webinars that are not yet scheduled, so please visit the URL there at the bottom to get the latest on the dates of these webinars and how you can register for these webinars. So that's chock full of content today. Thank you very much for the patience and listening in to this webinar. We have a few of you who are constant listeners to this webinar. We truly, truly appreciate your time, and my only desire, the reason why I do this is so that we can continue to educate you on the cloud so that you can further help your businesses, moving forward with their digital transformation, and also help your own careers as well. So thank you very much. This has been Hertz from Microsoft Philippines. See you in the next webinar, and I'll see you in our next events. Goodbye and have a great day. Thank you.